Hi, Professor. This is going to be our code explanation for the first part of the lab. So I will just say beforehand, we just played a video of our demonstration. So you can see in the video that we have it connected to the cables in the back instead of connecting to that port A. So we used the jumper wires. And then we also played a sound that increased in the frequency and pitch as we got closer, and then obviously did the same when we went further away. And then it also vibrated with an increasing frequency as we got closer to the sensor as well. And then again, when we moved back from it. So I'll go ahead and show you the code. So this is our CPP main file that we're using. So we've got the unified library and the Adafruit library. Here we just have the Adafruit VCNL 4040, making sure we're able to access that. And then our variable definitions for our vibrate and make sound. And then in our make sound, we're going to be taking in a frequency parameter. In our setup, we just start it. We set the volume to 64, not too quiet, not too loud, and then set the power of the set vibration to 1, which is active. And then we show that the Adafruit VCNL config demo is just to make sure that it's working. And then if it doesn't work, we can't find it. If it does work, then we'll say that it was found. Then in our loop, we're going to start by accessing our proximity value by getting that proximity. And then I changed it where we used to be able to access the light information too. That wasn't really necessary for this lab, so I got rid of it. So we just have the proximity value being outputted just to see that something's working. And then we have that base frequency of 10,000. So that way we can make sure that it's noticeable and that it's actually working. Then for our vibration frequency, it's going to be that base frequency divided by the proximity value plus 1 to make sure that that is active and working and that we can hear it and feel it. And then here we're just going to actually call those methods, or the methods that we described earlier. So the make sound, which takes in the proximity value, and then vibrate. And then we'll just delay it based on the vibration frequency, so it's not going too crazy and you can actually hear the difference. And then in our vibrate method, we set the voltage to be on. We have the 3.3 volts. So that's what we've got here. And then we delay it for the 100 milliseconds. And then we turn it off just to make sure, again, that we can kind of hear the difference and that it's not just one long going vibration and you can feel or hear the difference. And then we have the make sound method. So again, taking in the frequency, this is going to be the speaker.tone. So it takes the frequency times 10, and then we have it set to the 100 milliseconds. And then right here, we have the true value as well. So that just makes sure that the sound is being created. And then, so that is, like I said, our CBP, and then that's all we need for that one. And then down here, you can see that it's already running. So we've got some values. So we have this, the Adafruit and then the found, and then you can see here that I started getting closer to it. So let's see, here we go. So you can see as I move closer, it's going to start picking up those values, and you can obviously hear it in the background just to show that it's working. I also want to make sure I include the platform INI file. So here you can see that we are using the Adafruit VSNL 4040 and the M5 Unified. For some reason, I was getting weird messages if I didn't download this Adafruit bus.io. So I just included it in the libdubs, but I'm not actually calling it at all up here in my files, but I do have that as well.
All right, so I'm going to show you the Thursday part of the lab. You can see we have successfully hooked up the gamepad QT, and you can see that we have the implementations working for moving the dots around. You can see I'm using the joypad, and then we could also use the buttons right here. And so you can also see that we can also change the speed. So the speed's pretty fast right now. If we were to hit start right here, we hit start, you could see that, let's hit it one more time. There we go. So now I pressed the wrong one. So I hit select and you can see the speed is a lot slower, which is working as intended. And then if we get close to the other ball, game over. It looks like it was a total time of 100 seconds. Kind of hard to see, but game over, total time. I promise it says 117 seconds. I want to show it to you if I can. Yeah, it's just hard to pick up on the camera, but it's 117 seconds. And then I'll show you the code real quick. So we'll make this a lot smaller. Awesome. So we're using the I2C value of the I2C 0x50 port. So at first I was using OX49 for a long time and I wasn't able to initialize or connect with the gamepad, but all I had to do was change this to OX50 and that works great. I was also able to find the specific pin numbers. So for things like the Joy-Cons, you could see that the Joy-Cons going up and down, they have a specific pin number. And then also these are the specific pin numbers for button A, B, X, Y, start, select, things like that. So yeah, was able to look up a lot of the documentation on how to kind of do this and basically how to use the gamepad QT and how to hook it up. Hooking it up took the majority of the time. And then we also have the end game sequence near the end. It checks for collision, and then if it is true, if we do collide the two dots together, it keeps track of the time, the game time, and it outputs game over with the specific game time in this format, which is working correctly. So that is the Thursday lab section completed and working correctly.